All right, here we go. So what's different? What's different about this question from all the other questions we've been doing for the last hour and a half? There's an equal sign. Yeah, do you guys notice that? There's an equal sign. The ones we've been doing for the last hour and a half didn't have equal signs. They didn't. This is like a wall, left side, right side. We haven't had equals. Right, that's what's new in this section. So let me give you a game plan. When you've got x squared with an equal sign, I'll give you the recipe, the steps, the game plan that we'll use for the next, what do we got? We only got a half an hour. Man, I got to get through some word problems. No, we got 40 minutes. Good, okay. We got 40 minutes. I got to get through some word problems. So, when you have x squared with an equal sign, step one is actually to get a zero. This will become really important. We'll use this throughout the course. Start streaming this into your long-term memory right now. Do you know how to do that? I'm just kidding. I don't know how to do that either. But do the best you can. This isn't just like a short-term thing we're just going to use for the next test. These steps I'm going to give you, we're going to use this till the weather is warm in May. We'll just keep doing this and doing this and doing this for every chapter. Get a zero. Factor. Like the two parentheses. That's why we spend all this time learning to factor, because this technique is super important in stuff we'll do the whole semester. Each part equals 0 and solve. So there's the game plan. When you see x squared with an equal sign, it needs to become in you over the next month just a knee-jerk reaction. Get a 0. Get a 0. Somebody wakes you up in the middle of the night and says, x squared with an equal sign. You say, get a 0. That's just got to be the automatic reaction. When you see x or b squared and an equal sign, when you see those things, you think, get a 0. So that means jump this 32 over so that we'll have 0 on the right side. What happens when something jumps over the equal sign? Changes signs, huh? So that'll become b squared plus 4b minus 32, huh? Equals 0. So we did step 1. We got ourselves a 0. All right, step 2. Factor. You guys are lean, mean factoring machines now, right? You can factor that with the greatest of ease. So do so. 2 parentheses. You can factor small polynomials in a single step. So front times front, b and b. What two numbers multiply to be 32, add to be 8 times 4? Good. And how do you know the signs? Sign in the middle is always taken by the bigger. The other one can be the same or opposite. It'll be negative 4, right? Because plus 8 minus 4 makes plus 4 in the middle, and they multiply to be negative 32. Good? So that's step 2. Factor. I factored it. Step 3, what do we do now in step 3? Yeah, each part gets its own equal 0. So the b plus 8 equals 0, or the b minus 4. They each get their own. Now, why? Have you seen that before? You might have seen that before. Why? Well, why is that okay to do? Why can I go from 2 parentheses 1 equals 0 to they each equal 0? How's that true?
Because one of them has to be 0.
Why? Why does one of them have to be 0? See, what do you mean? Something gets 0, something has to be 0.
A term has to be 0.
Why does it have to be 0? Because they're multiplying. Very good. Exactly. That was the key word I was looking for. Because if you're adding 2 things and they equal 0, neither one has to be 0. But if you're timesing them, just think with me. What if, hey guys, I'm thinking of 2 numbers, man. Okay, I am. In my little head, I've got 2 numbers, and I'm timesing them, and the answer's coming out 0. What does that mean? What do you know about one of my numbers? One of them's got to be 0, right? If I'm timesing them and it's coming out 0, doesn't one of my numbers have to be 0? Could the first one be 0? Yeah, it could. 0 times anything would be 0. Or the second one could be 0, right? Because anything times 0 is 0. Well, that's what this is saying. It's talking to you. Are you hearing it? It's saying something times, right? Parentheses are times, right? Something times something equals 0. So therefore, the first one could be 0. Or the second one could be 0. Either way, they would times to be 0. If either one of those was 0, huh? That's why that's right and true and logical. Okay, so now we just finished from there. So how do you finish solving that thing? Just jump the 8 over, right? Becomes a negative 8. Jump the negative 4 over. Becomes positive 4. There's my two answers. How do they want you to enter it? They want you to just put both answers in. You don't need to put the plus on the 4, just regular 4. Just put them in with a comma. No parentheses. Either order. Both answers with a comma. We're done. Does that make sense? On that? Questions on that? Hey, are those answers right? I mean, if I went back up to the beginning and I put in, let's say, negative 8. If I put in negative 8 here, squared, plus 4 times negative 8, would it equal 32? What's negative 8 squared? 64 plus 4 times, see, I'm just plugging in negative 8 for B. Did they tell? We're saying negative 8's an answer, one of the two answers. So negative 8 squared is 64. And 4 times negative 8? Minus 32. Does that equal 32? Yeah. How about 4? Does 4 work also?
Yeah.
Let's go back and see it. If I put in 4 for B and 4 for B, right? B can only be one thing at a time, right? It's either negative 8 in both cases or 4 in both cases. So 4 squared, that'd be 16. Plus 4 times 4?
16.
16. Does that equal 32? Yeah, beautiful. Look at that. How's it doing that? It's logic. We just followed logical truth all the way. So that is the truth. Those are the two numbers. No other numbers make it true. Try any other number you want. It's not going to work. Try putting in like a 1 or a 0 or a 5 or anything you want. Put in a 1. 1 squared plus 4 times 1, that's what? 5. That's not 32. Right? No other numbers will work. Just negative 8 and positive 4. All right. Step 1's already done, right? Step 1 is get a 0. Whenever you see b squared with an equal sign, think get a 0. That's already done. Check. Step 2. What's step 2? Factor. Some kind of factoring. Yeah, how do you factor that one? That's not two parentheses, is it? What's the first step in every factoring problem? GCF, right? Take out what's in common, huh? One parenthesis, right? This is why we spend all this time factoring. So we can do it now that it's needed. Okay, so we take out a b, huh? Leaves b plus 2. We all good there so far? Right? That makes sense. If that b went boom and boom, it'd be b squared plus 2b. Right? Everybody good? So that's step 2 factor. What's step 3? Each one equals 0, huh? So the b alone, that's the first one. And the other one's the b plus 2. Everybody tracking with me. Each one. So the b alone is 0, and that one's just done. Or the b plus 2 is 0. Right? Because the two things times to be 0, either one could be 0 to make that true. Jump the 2 over. Negative 2. So the answers are 0 and negative 2. Just put a comma between them. Is that really true? Let's go back. Let's put in the 0. Is 0 squared plus 2 times 0 0? Well, yeah, we should have guessed it, that one, huh? That's like obvious now. But how about the negative 2? Negative 2 squared plus 2 times negative 2? Yeah, that's 4 minus 4, that's 0. Isn't it beautiful? Math just goes right to the truth, doesn't it? Because we followed truth all the way. Questions? How many got those answers? I want to see where you're at. So speed up, slow down. Okay, looks like majority. All right, I'll keep moving. You stopped me, though. I'm glad. The game plan I just gave you, you know, when I said if you have x squared, let me refine it a little bit now. If you have x squared and x to the first, with an equal sign. Yeah, do that plan. You know, get a 0, factor, each part equals 0. Right. But if you have x squared and no x, like this one, see how there's no x to the first anywhere? See what I'm saying? We just have x squared and numbers. No x to the first power anywhere. Right? Right, let's look back. See this last one, number 3, we had b squared and regular b to the first power. The one before it, there's a big mess there. It is b squared and regular b, right? So, yeah, if you have x squared and regular x, yeah, do the method I've been telling you. But if you have x squared and no x to the first, like this one, there is an easier game plan. Just get x squared alone. Step 2, put root and plus or minus root over the sides, and you're done. So that's all you need to do. So I'm going to put root and plus or minus root. Just a quicker way. You don't have to get 0 and factor and all that stuff. The root cancels the square, and we just get x. What's the square root of 25? So the answers are plus. That means 5 or negative 5. Both are answers. Do you see why we did the plus or minus? Because there really are 2 answers, aren't there? You could put in here 5 squared or negative 5 squared. Either way would be 25, wouldn't it? See why we need to do plus or minus? All that. Over the years of teaching this stuff, I've noticed that many students forget the plus or minus when they put the root. So my job as a math teacher is I sit around and I think, what kind of analogy can I say to help them remember that when you put a root on, you've got to remember the plus or minus. Everybody was forgetting it on the test all the time. So I made up a really dumb saying. It's my dumbest, I think. But I've got some dumb ones. But anyway, so when you put a new roof on the house, you got to go up and down the ladder. Sorry. There it is. So in other words, if you put a root, right, when you put a root over the 2 sides, like a roof on the house, best I can do. A root, when you put a new, if you're going to put a new roof on your house, you couldn't do that without a ladder. You'd have to go up and down the ladder. So that's the plus or minus, best I could do. Up and down, plus and minus. So when you put a root on both sides, you've got to go up and down the ladder. You've got to go plus or minus. So don't forget, when you put a root over both sides, you've got to go plus or minus, or you're going to miss one of the 2 answers. All right. Yeah, you know what I would do with this one? This one has one little trick. I just want to show you the trick on this one. So here's another, v squared. So, with a regular v. So we're going to get a 0. It's actually got a 0 already. Factor. It's going to be pretty much the same. The only issue is they're out of order, and this guy has a minus in front of him, huh? Remember, we never liked the biggest term, the v squared, to have a negative in front. You know what you could do that'd be real easy? Do what? Jump them to the other side? Exactly. That's exactly what I was saying. Just jump everybody over here. They'll all switch signs, right? Like that. So you get 0. This will be v squared minus 3v minus 18. Then it's a piece of cake from there. Does that make sense what we did? I just jumped. So if you're not happy with the signs of the front term, just jump them to the other side. All the signs switch. Can you take it from there? Can you factor? And then set each one equal to 0. So, what 2 number, remember you multiply and you add to be the middle. What 2 numbers multiply to be? What times what is 18? 6 and 3. And sign in the middle goes on the bigger. Minus 6 plus 3. That adds to be negative 3, multiplies to be negative 18. So there it is, v minus 6, v plus 3, right? Am I going too quick on that? Remember the diamond thing that we learned?
Would you say that the two numbers are usually closer together and further apart?
Yeah,
Like
the-
2 and 9
Right.
aren't likely candidates.
Yeah, exactly. We do the 6 and the 3 instead of the 2 and the 9 because they're closer together. Exactly. Thank you. Is that good to there? Right? So that's step 1, get a 0. Step 2, factor. Step 3, each one gets their own 0. Right? Like that? And then just jump it over. Jump it over. See how it's just always going to be opposite sign, huh? So the answers are 6 and minus 3. Good on that? So the moral of the story, if you don't like the sign in the beginning, just jump all the stuff to the other side. It all switches sides. It's nice to have the front term not having a negative. It's just easier to deal with. All right. An envelope, which means a rectangle, right, is 3 centimeters longer than it is wide. The area is 88. Find the length and the width. Find the length and the width. So an envelope is 3 centimeters longer than it is wide. The area is 88. Find the length and the width.
Did you give them some keywords? Like, here's the word in English, translate it to math.
Yeah. Good idea. Let me give you, there's going to be 3 formulas in this section. Let me just give you those ahead of time. Area of a rectangle. Envelope's a rectangle. What's the area of a rectangle for me? Anybody already know that one? Yeah, length times width. You remember that one, right? Imagine if you had one that's it's two squares tall, 3 squares wide. How many total squares would there be? 1, 2, 3, 4, 5, 6, huh? So the area is just one side times the other, right? Space in the middle of a rectangle, right? And by the way, that's why we call it square units. You familiar with that? If this is 2 feet and 3 feet, then in there is 6 square feet. We mean actual squares, foot by foot squares, right? It's a foot by foot square is about like this, right? It's 1 foot by 1 foot square. So when we say something's 2 feet by 3 feet, the area inside is 6 square feet. By carpeting or tile, it's sold in square feet. They mean actually how many squares, foot by foot squares. So square units. We don't have to do anything with the units, but just want to let you know. All right, number 2. What's the area of a triangle? Does anybody know the formula for area of a triangle? So the area, we'll get to that one in a minute. Area, isn't it half a rectangle?
Yeah.
Now really I'm simplifying it, but, right? That'd be a whole rectangle, right? So a triangle is half a rectangle, isn't it? So it's a half, and you call it base and height, length and width, Joe and Tom, whatever you want to call them. It's half of one side times the other, because it's half a rectangle, huh? That makes sense? Okay, and third, there's something called the Pythagorean Theorem for right triangles. Do you know that one? So this is another one for triangles. Yeah, exactly. A, B, C. A squared plus B squared is C squared. So there's the 3 formulas we're going to use in the word problems in this section. It's going to be those 3. So you just got to identify which formula and then just start using it. Remember the Pythagorean theorem here? Remember this is for a right triangle, a 90-degree angle. Right angle in that triangle. And side C has a special name. You remember it? Yeah, it's called the hypotenuse. This side is called the hypotenuse. Because it's the longest side, isn't it? See how C is longer than A or B? Right, A squared and B squared adds up to be C squared. C is longer than A and B. It's the one across from the right angle. The other two sides are called the legs of the right triangle, and the hypotenuse is the side not touching the right angle, across from the right angle, the longest side. Hypotenuse. All right, so those are the three formulas. We're going to be using those three. Let's go back to number 12 here. Envelope. So which one are we doing here? Well, they're talking about area. And an envelope's a rectangle. And they're talking about length and width. So what formula am I going to use? Area is length times width, huh? Area of a rectangle formula, right? Number 1 here. Area is length times width. All right, so there's my formula. Let's plug in what we can. They're telling me the area is 88, so I'll just put that right in for A. Put it right in there. You don't need to do anything with the units. You don't need to mess with centimeter squared or don't even worry about it. Just put the number in there. 88. Okay. Now what about length and width? What am I going to do for that? I can't use both letters. I only want one letter. What am I going to do? It says that it's 3 centimeters longer than it is wide. You know what? Let me make this easy for you. You could just call one of these x and the other x plus 3. It doesn't matter. Does that make sense? When they say 3 longer, doesn't that mean x plus 3? As we dealt with in other word problems. Just call one of these x, and now technically I have it reversed. It doesn't matter. It'll all be easy to straighten out in the end. One of them is x, the other's 3 longer, so it's x plus 3. And they're times, right? L times W. So now, can we solve that equation? Distribute. What do I get when I distribute there? In fact, let me go to a fresh screen. What's this, number 12? So number 12, A is length times width. What was it? 88 is x times x plus 3. Distribute. X squared plus 3x. Get to there. What do we do now? Yeah, remember the game plan? When we see, that we just went over, when you see x squared with an equal sign, step 1, get a 0. Huh? X squared with an equal sign has suddenly appeared. You know the game plan. Jump this 88 over here, producing a 0. So step 1, get a 0. We got it. What's step 2? Step 2, factor. So you know how to factor. You guys are pros at factoring now. What two numbers multiply to be 88? What times what's 88? 11 and 8. Sign in the middle? On the bigger. Okay, to there, plus 11 minus 8 is plus 3. That's step 2. Factor. Step 3. Each one equals 0, huh? They each get their own 0, so I get x plus 11 is 0, or x minus 8 is 0. Good so far? Little surprise is going to come here now. You with me? Is tracking? Go solve for x. Jump it over. Negative 11. Jump it over. Positive 8. So we got negative 11 and positive 8. So that's our length and width, right? We got it. Length and width. Easy problem.
Which one's the length and which one's the width?
Yeah. What did it say? Good question. Which one's which? What did it say? It said what did it say? 3 centimeters longer. So which one's bigger, length or width? 3 centimeters longer than it is wide. The length is bigger. The length is bigger, right? The length is 3 bigger. You with me on those words? 3 centimeters longer. Length is 3 more. So the length must be the 11. This must be the width. This must be the length. Got it. Well, there's a couple problems with that.
Nothing can measure
Yeah. What if I took my tape measure? Mr. Wright, how wide is it? I'll measure. It's negative 11. It came out negative. It's weird. I don't know why. No. Right? Real life things can't have negative widths or lengths or heights or bases or whatever. That can't be. Why are we getting this negative answer? Because math isn't real. Did you know that? Math is made up. They just, really? Well, what are we doing here? Class over. Right? Now that this is out. No, is that news to you? Math is not real. I'm not kidding. It is not. I don't think you ever sat around and thought carefully about it. Right? What if I said I saw 3 on the way to class today? There it was, 3. You'd go, what do you mean? You saw 3? You saw 3 people or 3 cars? No. I didn't see 3 people in college or three objects of any kind. I just saw 3. You'd be like, what do you mean you saw 3? You saw like the number 3 like spray painted on the wall or 3 in a cloud? What do you mean? No, I didn't see the number 3 spray painted or written anywhere or 3 objects. I just saw 3. I'd be ready for the rubber room, right? Because you can't, math is made up, right? You can't see them. Now, it's made up to describe things that are real. It has a real use, but it itself is imaginary, isn't it? Right? Numbers are made up. We made up 3. Why? So that we could deal with things in the real world, we can communicate about them. If I saw 3 cars, black soda McKinley, head-on collision, before class, I did it. But I can come to class and say, hey, I saw 3 cars, head-on collision. Now, you know the concept of 3ness? I know the concept of 3ness, which is made up to describe things that are real. We can communicate about things that are real. So math is made up to describe things that are real. Right? We've made it up. Think about it, you might know if that, I don't know if that sounds weird to you, but think about all of science. Made up when you're doing a real life word problem, you have to keep one foot in reality and one foot in math and throw this silly answer away. Math doesn't know about the real world in which we live. Like I said, it's made up. Math is just running numbers, and it's just saying, those numbers work. We go, well, math, in the world we live in, things can't be negative lengths and widths. So forget that, throw that away. So then what's the other answer? Well, then you just go back to reality. What's the reality? 3 centimeters longer. The length is 3 more than the width. That's what the words say. I can read those words, right? So then you go, okay, well, if the width is 8 and the length is 3 more, the length is positive 11. And that's often what happens. The negative answer you throw away is often the other positive answer. Not always, but often. Does that make sense? We got to do like 4 more word problems, guys. Hold on. We got. I'm not really going to get 4 of them done, but maybe 2. Is that good there? All right. So, all right. Base of a triangle, 5 centimeters greater than the height. Area is 18. Find the height and the length of the base. So they got this nice little picture. What formula? Remember those 3 formulas I gave you? Which one are we going to use here? Area of a triangle, which is a half base times height, right? In fact, let me just draw the picture for you. That's all we need on this one, whoops, is the picture and our formula. What was it? It was h plus 5 and h? Okay. All right. Area is a half base times height. Area of a triangle. Okay, and so now what did they tell me the area was? Oh, 18. There it is. So area is 18. Let me write that in. Area is 18. So grab that and pop it in right there. 18 is a half. Now, what do we do for base and height? Well, clearly we're going to use this and this, huh? So just put them in. I'm going to put the h in the front because it's just easier that way. It doesn't really matter what order. We good so far? All is well so far? Now, what do we do from there? What do we do from here? Well, yeah, but which we will do in just a second. Yeah, but you know what? I would like that half is bugging me. Basically, a lot of people, this question's often on the test, and a lot of people get tripped up by that half. So let's do something about that half right away. Let's just get it out of there. Fractions are a pain. How can I get rid of that half right away? Multiply, exactly. Multiply by 2, gonzo. And remember, when you do the front of a parenthesis, you don't need to go in the parenthesis, because whatever you do to the front will eventually distribute in on its own. So we've done it. So this is 2 times 18, 36. The other side, the 2.5 cancel. You tracking with me? Are we good to there? Now, where are we going to go from here? Now we distribute h squared plus 5h. How are we doing? Is this making sense? This trips up a lot of people on the test. They get stuck with that half. They don't know what to do with the half. Are you tracking with me? And then what do we do from there? So what's the plan when you're solving x squared with an equals? Step 1, get a 0, huh? So I'm going to jump this 36 over. And it becomes a negative 36. And we got a 0. Like that. Step 2. Factor. So I'm running out of time. I want to get another one in, so I'm just going to factor it quick. What times what's 36? Yeah, 9 and 4. Sign in the middle is plus. Plus on the 9, minus on the 4. And then h plus 9. Then each one equals 0. Jump it over, jump it over. H is minus 9. That's impossible. So the height is 4. And the base, right there, add 5. Sure enough, it's the negative answer we threw away, but the positive version. The base must be 9. Is that good? I want to get one more in that'll be important to have in your notes. Questions on that one? This is all going. A wire is stretched from the ground to the top of an antenna tower. The wire is 35 feet long. The height of the tower is 7 feet greater than the distance d from the tower's base to the end of the wire. Find the distance d and the height of the tower. Wow, that's tricky to follow, huh? So let me show you. We basically have this wire that's stretched. This is the tower over here. We're stretching the wire. The wire is stretched from the ground. Down here's the ground. The wire is 35 feet long. So I'm going to say this wire is 35 feet long. The height of the tower is 7 feet greater than the distance d from the tower's base to the end of the wire. This is d down here. And this is d plus 7. Does that make sense? 7 greater, d plus 7. Okay. Assuming that tower is built straight up, it's not the leaning tower of Pisa, so it got a right angle there, doesn't it? We assume they built it straight up. So, what formula? Remember the 3? I told you the 3 formulas. Which one is this one?
Pythagorean Theorem.
Yeah, look back for a second with me. Notice there's 2 triangles. The first one's rectangle. The bottom 2 are both triangle, aren't they? How do you know? Well, then how do you know which triangle one to use when there's 2 triangle formulas? One of them's area. The other is not area. So, go back to the problem. Did they say anything about area? No. This one's not area. It's triangle, but not area. So it's Pythagorean. It's Pythagorean, huh? It's a squared plus b squared is c squared. Because there's no area mentioned. It's triangle, but not area. So I'm not going to use the area as half base height. Because they're not talking about the area of the triangle. They're just talking about the sides, aren't they? So that's the Pythagorean. Now, when you use the Pythagorean theorem, a squared plus b squared is c squared, how do you know which one? The main thing to get right is the c. The a and the b are switchable, doesn't matter at all. But you got to make sure you get c right. He's alone, he's special. How do you know which one is c? It's the 35. It's the one not touching the right angle. See how these guys both hit the right angle? They're the a and the b. Either order doesn't matter. But the other one, the 35, that's the c, isn't it? So that's the c. The other two, it doesn't matter. D squared plus, and you got to put parentheses, d plus 7 squared. That makes sense there? A squared plus b squared is c squared. So then you got to work that out. You're going to get d squared plus, and then you square this out. What do you get? D squared plus 14d plus 40. What's 35 squared?
1225.
Thank you. And then d squared and d squared is 2d squared plus 14d plus 49 is 1225. And then what do you do? What do you do from here? You got to get a 0, huh? This is a terrible problem. Subtract 1225 because you got to get a 0. So 2d squared plus 14d minus, somebody got that? 11, what is it?
1173.
I don't, really? Is it?
Oh, wait.
That seems wrong to me.
1176.
You sure? It could be, maybe, I don't know, I'm just... Yeah, you're right, you're right. 0. So now we got a 0. See how we got a 0 there? You're supposed to now, this is a terrible problem. Now you should factor out a 2. That'll leave d squared plus 7d minus 500 and something. I don't know. 588. And then you got to keep factoring from there. Was I supposed to stop at 10 after? What time does our class end? Oh, was it? Is that what you guys were getting? I'm sorry. I thought it was 20. Sorry.